Hello, everyone. This is Arun Nandagopal here to talk about Docker use cases for robotics. So, in this video, I'll go through a use case where we use a different ROS distro on a non-compatible OS just by using Docker, and we also try to use a graphical user interface inside Docker. So this is how this video would go. I would first give an outline of what Docker is and how you would set it up. And post that, I would give the use case where you could apply it on your application and then conclude the whole thing. So why Docker? Docker is very important because it gives you an opportunity to play around with any of the ROS distros without having to abide by the OS requirement. What I mean is that if you have Ubuntu 22.04 and you have ROS 2 Humble running on it, you would probably not be able to run ROS Neotic and ROS Melodic or ROS Foxy. So, how would you run a program or a GitHub repo which specifically says it runs on a Neotic machine on a machine which is running ROS Humble? And that's where you can use Docker to get through this portion of it. So how do you set this up? To set up this, first you need to go to the Docker Docs website, and over there they have given a solid instruction on how to install it. So if you're running an Ubuntu machine, you would probably go to Docker's doc page, and then you go into Docker Engine tab, not the Docker desktop, and you go about going to install for Ubuntu. Once you're there on the page, you should go to this section where it uses curl to install Docker. So you would go about going through these commands over here, and suppose if you run into some error, this was an error which I ran into, and I was not able to run the run the installation file which was installed by curl. So to go over this, I had to remove my ROS1 and also Gazebo, which was there on Ubuntu 22.04 machine, and that's why it was giving this error saying that it's not able to update, get the release keys for these packages. So if you run into a similar situation, here you go. This is the solution to go over this. And if everything goes well, you would get something like this, which means that your Docker has been successfully installed. Another thing in Docker is that you would be, if you just do the just installation of the Docker engine, you would be having to run Docker in a root privileged mode. As in, you need to put in sudo before every command you give in. If that, so to go over that and make it just like how you would use ROS, you just say ROS run and so on. You could do the same way for Docker, and you just all the commands be Docker and so on. No need to add sudo. To do that, you add a group. So you would go ahead and follow these instructions in Linux post installation step for Docker engine, and you would go through all of these four steps which are described there. And after you go through all of these four steps, you probably need to reboot your system so that these changes take into effect. And once this is done, the way you would go about and check it is by running a simple Docker instruction, say a Docker run hello world. And if this one works well and it doesn't give out any error, awesome. You have installed Docker and you are able to run Docker without root privileges. But if you get an error saying that the Docker daemon was not found, probably you need to check into what the error is. And for me, the way I went about this is by removing this particular file, which was inhibiting my whole running Docker as a non-root user. So once I did this, then I was able to go about and do Docker run hello world. Um, so with this, you would be in a good state to go about and use Docker. So let's go dive deep into the use cases for Docker. Say you want to run this GitHub repo, which is reachability map visualizer, and this repository is in ROS Melodic, and it requires Ubuntu 18. So me having Ubuntu 22.04 and ROS 2 was at a place where I couldn't use this package. But then with Docker, you could potentially make a Docker container which runs ROS Melodic in Ubuntu 18, and then get this package into the container so that you can test whether this package would suit your application. So the primary stage is to create a Dockerfile. I wouldn't go deep into how to create it, what are the individual lines of code mean, because there is a very good YouTube video which I would point you to by Articulated Robotics. But the main thing in this is that you are having this line of code where it says from OSRF ROS Melodic Desktop Full. What this does is that it installs ROS Melodic in Ubuntu 18 machine, and then it sets up that container. And this run command is going to add all of these like these packages inside this container. Post it installs the ROS Melodic. And the following other commands are just are here so that you could use um, the Docker container as a non-root user, and whatever you create inside the container can be accessed on your normal desktop, and vice versa. So I wouldn't go deep into how this was done and what each line of code means, but I would point you to look into this great playlist, Docker for Robotics by Articulated Robotics, which would give you a better insight on uh, just the basics of what Docker is and how to set it up and all those things. So, in order to create a container, the first step would be to build an image based on the Docker file we have created. So now we have listed out what are the requirements which should be there in the Docker container. And so we build an image. And this is how you build an image using a Docker file. Once you do this, this creates a Docker file with Docker file with this name. Uh, sorry, Docker image with this name. And once an image is created, the next step would be to create a container using this image. And this command is quite big here. Probably you could just get away with Docker run it my image, but in order to use your uh, in order to bring up graphical user interface, you need to connect this X server, which is running on your machine, to the container, and that's how you could get any of the graphical user interface running through a Docker container. Um, some things which you need to look for is that this -b is a command to mount any of the folders onto this container or make it accessible when you're inside this container. So here I have this address where I'm looking into home around Docker files, and this is the GitHub package which I want to access inside the container. So I'm making it accessible inside the container under my Docker files. And similarly, I'm taking this temp x11 Unix, which is the port to connect to the X server, and placing it on the Docker container as well. And this set of commands, GPU all runtime, is used to enable your oops, is used to enable your graphics driver underneath this container, and also this environment sets like the display to the normal display you're using for your computer, and then you give the name of the image which you built using your Dockerfile. So this would create a container which could actually run graphical user interface programs like RVIZ. So I'll give you a demo of how I went about using it. So this command is for setting up the container. And once we have the container running, I use ROS core in the container. And then here, I figure out what's the container name. It auto generates the name. And we have to use docker exec dash it and the name of the container bash, so that you open the same container and you carry on the same containers. This is just like opening another terminal and running some other command after ROS core. So once you have that, you go into the GitHub package. You have just given access to the container, and then you do your normal sourcing, and then you do catkin make. And here you go. You now have successfully compiled a ROS package, which just runs on ROS Melodic machine on your Ubuntu 22.04 using Docker. So here, now you can run this package. Go ahead. Then now this package is running, and then you can again go into that same container and do the normal sourcing by getting into that catkin workspace, and then you run your RVIZ command. So here I have a particular RVIZ command where I'm loading a pre-existing config file, and this would bring about the RVIZ file, and then you could work just like how you would work on your own machine. So this is how you could use Docker to visualize anything. So I'd like to conclude by saying that the ROS version is no more an inhibitor to like test different GitHub packages. So if you know what your application is and you find some GitHub packages which can solve that problem, but the only thing is that it's in a different ROS version, you need not worry. You can use Docker, choose the ROS distro you want, and then run it on any OS and still get that GitHub package tested. So this is it. Thank you for listening and have a nice day.